Hi folks, we're going to take a look at number 4 from the Unit 5 Lesson 4 homework sheet. So here we've got a pendulum that swings back and forth 10 times in 8 seconds. So from here, right off the bat, I'll determine the period. So we've got our pendulum, okay, which goes back and forth 10 times in 8 seconds. So that means in 8 seconds, we complete 10 cycles because it's going back and forth. And so just 8 seconds divided by 10 means that our period is going to be equal to 0.8 seconds. All right. So of course, from this, we're going to determine the K value. All right. I think what I'm going to do first is I'm going to sketch the 2 cycles that they ask us to sketch here. So how we represent the distance of the pendulum really is up to you. So what I'm going to do is I'm going to let, in my algebraic model, I'm going to let the distance be the distance from the rest position. So the horizontal distance from the rest position. And they're telling me that I'm starting at the maximum extension. So that means I'm going to be starting at the maximum. If the rest position is my point of reference, that means, you know, one direction will be positive and the other direction will be negative. All right. So I'll call the positive direction the one I'm pulling it from. Okay, so if I'm pulling it to there and then letting it go, then it'll swing back and forth. So positive position, negative position. All right, so I can draw this graph pretty easily. Just start at the maximum and then just keep going down. So there you go. There's one cycle. And now let me just go and do another cycle. Okay, so the period would be 8 seconds. So that means this will be 16. This, say we'll call this T in seconds, and this will be D in centimeters, okay, which we'll define as the horizontal distance. Now we know that the total horizontal distance as it goes from its maximum extension to the other side is 40, so that means midway to the rest period is going to be 20. So that means that my Y scale is going to be 20 and negative 20. Okay, and that's it. That's as good a graph as I need for this scenario here. So from the graph, I can now determine, I don't actually have to calculate this, so I can determine here the amplitude is clearly 20, the distance from my axis, which is going to be at y equals 0, to the max or min is just going to be 20. All right, so A equals 20. My C value is going to be equal to 0. I don't need a phase shift, since I'm starting at the maximum and I'm going to use cosine as my parent function. All right, and my K value was just going to be 2 pi divided by my period. Okay, and my period here is 0.8. We should clean this up here. So 2 pi divided by, this is 8 over 10 or 4 over 5. Okay, and that's just 2 pi times 5 over 4. Do a little reducing, and so my K value is just 5 pi over 2. All right, so the model here is, I'll write it as D equals, the A value is 20, so 20 using positive cosine of 5 pi over 2t. Okay, no phase shift needed and no vertical translation needed. Okay, but since they're actually asking me to determine this model, I'm going to need to define my variables here. Okay, so here t is time in seconds, and here d is going to be horizontal distance relative to the rest position. All right, and that's going to be in centimeters. All right, and that's it. So again, step number 1 is to understand how this information helps us get the period of the pendulum. Step 2 was to determine how I was going to measure this horizontal distance. I chose to measure it from the rest position, so that's why I went from positive to negative, and then choose your parent function and determine your basic characteristics. And I believe the answer that's given in the sheet is a sine function. All right, so if you want to figure out how to do this with a sine function, clearly you're going to need a phase shift, but imagine what an phase shifted sine function would look like. It would look something like this. So if I need this maximum to start at 0, it means I would have to move this over to the left by a quarter period. Okay, so in other words here, in brackets, I would have t plus, and a quarter of 0.8, of course, is 0.2. So I would have 5 pi over 2 bracket t plus 0.2. And that's really the only change that would be necessary for this model here. All right, that's it for this one.